Hi, I'm Sean Gannon, and this is Minute Math, and today we're going to learn about differentiation, and we're going to apply the quotient rule. We're going to differentiate each function with respect to x. So if I was given this function, y equals 3x to the fourth plus 2 all over 3x to the third minus 2. My numerator I'm going to label f, and so that's 3x to the fourth plus 2, and my denominator I'm labeling g. 3x to the third minus 2. I know with my quotient rule, I'm going to find f prime and g prime, so let's do that. F prime, product rule, or power rule, sorry. So we have 12x to the third power, and g prime, again, power rule gives us 9x squared. So now let's go apply the quotient rule written up there, dy dx is equal to, well, f prime, 12x to the third times g, which is 3x to the third minus 2, minus f, which is, oh my goodness, I just wrote f instead of the function f, or the part f that we have here, just wrote f down, 3x to the fourth plus 2 times g prime, which is 9x squared, all over my denominator squared, which is 3x to the third minus 2 squared. So now let's go multiply this out. dy dx, 12 x to the third times 3x to the third gives us 36. We have 36x, add the exponent to the 6th power, minus 12x to the third times negative 2 is a negative 24x to the third. Now make sure we distribute this minus sign to both parts. Minus, well, 3x to the fourth times 9, 3 times 9 is 27. So we have 27, subtracting 27x to the exponent 6th power, then minus again 2 times 9, which is 18x squared. All over, if you want to show a work for that right here, 3x to the third minus 2, the denominator, 3x to the third minus 2. To foil that, we have 9x to the 9th power, minus 6x to the third, minus 6x to the third, and you'll probably get better at this, we don't have to write it out. 9x to the 9th minus 12x to the third plus 4, okay? We're doing all this together. Oh, not 9x to the 9th, sorry, that's the 6th power. Can't believe I did that. Be careful with that. We add the exponents, 6, okay? See if you caught that. If you caught that, put it in the comment section below. All right, so now I'm writing this out. We have 9x to the 6th power minus 12x to the third plus 4, okay? So, do I have any like terms in the numerator? Let's see if I can simplify this and rearrange this. I'm trying to also think, is there a like term I can pull out? And 9, 12, and 4 have no common factors, so that I can maybe simplify something for up top, so there's no point necessarily pulling a common factor up top if there were any. And so when I rewrite my final answer here, dy dx, I want to combine my like terms. I have 36 and x to the 6, and then minus 27 x to the 6. Both of those x to the 6th power, I can combine those two. And so 36 minus 27 comes out to be 9. Okay, right? 9, yeah. So we have 9 x to the 6th power. I use these two up. Now the third power is left, minus 24 x to the third minus 18x squared. All over my denominator, 9x to the 6th minus 12x to the third plus 4. And there we have our final answer and our derivative. So let's recap. We're given our function y equals 3x to the fourth plus 2, which I labeled to be f, over 3x to the third minus 2, which I labeled to be g. I then found f prime and g prime respectively. From there, I then applied the quotient rule, which was f prime times g minus f times g prime all over g squared. I then simplified and showed some work on the side here for that denominator. And as part of my simplification, I got to my final answer. So at this point, I found the derivative. Everything after that is just algebra. Okay, so the only calculus part that's going on is right here, or from here to here. Other than that, the rest is just algebra. And so now I have my final answer, my final derivative, dy dx is equal to 9x to the 6th minus 24x to the third minus 18x squared, all over 9x to the 6th minus 12x to the third plus 4.